So hi everyone, welcome to Electronics Techie. This is the day 3 of learning something about digital electronics. So here today's topic is our logic gates. So what is mean by logic gates? So the definition of the logic gates is looks like this. So logic gates are the basic building blocks of the digital circuits and systems. So further see what are the digital circuits and the systems? The basic building blocks means whatever the circuits are going to design related to the electronics. So the basic thing we are going to build by using the logic gates only. A logic gate is an electronic circuit made using diodes. How the logic gate is going to be made? By using logic gates we are building the digital circuits and systems like that. But how you build a logic gate means by using diodes, transistors, resistors. By using these components we are going to design these logic gates. So it performs the logical operation. What is the purpose of this logic gate? It is going to perform the logical operations where it is going to perform in digital system. What is digital system mean? We all know about computers, laptops, communication devices. These are all the digital systems. So these digital systems, when you are going to operate these all in the logical way, so on that time these logic gates are going to helpful. So for logical operations in the digital systems, these logic gates are going to be helpful for us. So logic gates work with binary inputs. So how these logic gates are going to be work? What are the inputs we are going to give means by using binary inputs we are going to logic gates are going to work the process what we are going to give. So what are the binary inputs? So you know that binary inputs are zeros and ones. So they can take two or more inputs. So logic gates are considered two or more inputs except NOT gate. Not gate consider only one input. So by using two or more inputs the logic gates are going to be work. Always produce only one output, but it consider two inputs, but it will produce only one output at a time. So if it is a gate, any gate it will be. So logic gate, it will be logic gate. Output will be 1. 2 or more inputs, but the output will only be 1 except NOT gate. Okay. The output depends upon the combination of the inputs. So how the output? What is the output? Either 0 or 1. It will be completely depend upon the what are the input combinations you are going to given. So then only we decide that output. Okay. So next type of logic gates. So how many types of logic gates are there? So if anyone asks what are the logic gates, then everyone simply say AND or not, NAND, XNOR like that. But if anyone asks what are the types, how many types, then someone will maybe blink like that. So maybe somehow they don't know about types of logic gates. They just only read about what are the types of gates means. So they are saying simply this type of gates. But in that also there is a classification in that logic gates. So in that classification, AND or NOT are the basic gates. So NAND, NOR are the universal gates. So XOR, XNOR as the derived gates. So here is some confusion. So what is that? Why NAND and NOR? So main interview question is going to be asked is why NAND and NOR gates are only going to be called as a universal gates. Is there any reason or any purpose they are going to ask? So then you have to give answer like that. So by using these two gates we can realize, so means we can design any other gates. So AND or NOT, X or XNOR. By using this NAND and NOR we are going to design any other gate. So by in market we have what is the use by using this design by using NAND and NOR we are going to what is the purpose means in market maybe NAND or NOR gates are going to be available, but your purpose is going to design about AND gate, but in market there is no AND gate. What you are going to do by purchase this NAND or NOR gate, then you are going to design this particular gate. Okay, then you have another doubt. So means if there is NAND means okay, in further class we are going to discuss about, now it is not necessary I think so. So okay, these are the types. So why if anyone asks why NAND and NOR are the universal gate means you have to simply say that by using this NAND and NOR only we are going to design any other gates. So what are the basic logic gates? So the first one is the basic logic means basic gates. So in the now we are going to see about the basic logic gates. So AND gate. So first one is the AND gate. So what is the definition of the AND gate? An AND gate is a digital circuit. So it is one of the digital circuit that has two or more inputs. In AND gate it has two or more inputs. The AND gate symbol is seems like this. So it may be two inputs or more than two inputs. Not only particularly how to say only two. So it is two or other than two or more inputs and produces a single output. So the output will be only the one. If it is two input or three input or four input or more than two inputs, but output will be only going to be 1. The symbol is seems to be like this, which is the logic end of this input. The logical AND operation is represented by the symbol of dot. So the AND gate is nothing but the product operation, means nothing but product between the two inputs or multiple inputs. So if you consider A, B are the two inputs, so the output of the AND gate is A dot B. Here you can see A dot B. Y is equal to A dot B. So the logical AND operation is represented by the dot symbol. Here I represent with dot. So this will be the representation of the AND gate. So operation, if both inputs are 1. So if both the inputs are 1, then the truth table of the AND gate seems like this: 0, A, B, and the Y. 0, 0, 0, 1, 1, 0, 1, 1. So 1 minute, I will change the color, then it is easier. Okay. A, B, and the Y. Here I am going to write. Let us ignore this thing. So 0, 0, 0, 1, 1, 0, 1, 1. So these are the, when you are going to consider two inputs NAND gate, then the how many combinations you are going to get? There is a two inputs A, B. So 2 square is nothing but 4. So we get 4 combinations. What are those? 0, 0, 0, 1, 1, 0, 1, 1. So 2 power n. Here n means number of inputs. So n means number of inputs. Okay. So the output will be A dot B. So nothing but a product. 0 dot 0 is equal to 0. 0 dot 1 is equal to 0. 1 dot 0 is equal to 0. 1 dot 1 is equal to 1. So now how can you classify? That means if both the inputs are 1, so when I see both the inputs are 1, then only the output is going to be 1. If any one of the input is 0, see here, if any one of the input is 0, then the output will become 0. So we are going to define the truth table is in this format. NAND gate is one of the digital circuit. It has one or two inputs and produces only one output. It will be represented with dot symbol. So coming to the truth table or operation, so if both the inputs are same, means 1, so then the output will be 1. If other case, if means if any one of the input is going to be 0, then the output is going to be 0. So like that we are going to define the AND gate. So coming to the next gate, so that will be the OR gate. So now you understand about the what is the how you are going to write this definition. So same to the other gates also. So OR gate. So the definition of the OR gate is an OR gate is also a digital circuit that has 2 or more inputs. It also consider the OR gate symbol seems like this. So it also consider 2 or more inputs. Here I will draw 2 input OR gate. So A plus B. So here we can represent with plus representation, and the produces a single output, which is the logical OR of these inputs. So here what is the symbol between the two inputs? So it is the plus. So nothing but sum operation. OR gate is nothing but sum operation, means it will produce the output of the sum of the two inputs. Where coming to the AND gate, it will produce the output of the product of the two inputs. So how we are going to define the operation means first we have to draw the truth table. So A, B, output is nothing but A plus B. So 2 inputs means 2 power n. So n is nothing but number of inputs. So 2 square is nothing but 4. So 0, 0, 0, 1, 1, 0, 1, 1. So the output will be 0, 0 plus 1, 1, 1, 1. So now how are going to do the same? If 2 inputs are 0, then our output will become 0. If any one of the input is going to be 1, our output will going to be 1. So like that we are going to define. Here see, if any one of the input is 1, output is 1. If both the inputs are 0, output is 0. Like that we are going to define the gate. So means everyone take it is easy. Means OR gate is AND gate is a simple one. But in interview, if anyone asks you to give demo on particular gate for 1 or 2 minutes, then you have capable of explaining that particular gate prolonged to the 2 minutes. But you know simply about the truth table. 0, 0 means 0, 0, 1 means 1, or it will be OR gate is nothing but A plus B. You can't say this in within seconds. So you have to elaborate and you have to explain in clear, in detail with the definitions and some prolonged things. Then you have to know the proper understanding of that particular gate. So you have to note down the every point. Okay. So next one is the inverter. So inverter is nothing but we also call it as NOT gate. So NOT gate is also called as inverter. So this is the invalid thing. So just ignore this thing. So coming to the next one. So it is a digital circuit that has a single input and single output. Our NOT gate seems like this. So single input and single output. So A bar. So it will be the complement of the input. So output is a logical inversion, means complement of the input. So if the input is equal to 1, our output will become to 0. Here A is means A output. Output is nothing but A bar. If you give input as 0, you get output as 1. If you get input as 1, you will get output as 0. So if the input is equal to 1, output will become 0. If the input is 0, output become 1. It is the operation. Hence it is called as a inverter. So this is about the NOT gate. So coming to the next type of gates, it is the universal gates. So coming to the universal gate, first one is the NAND gate. A NAND gate is a digital circuit that has a 2 or more inputs. Same definition for the everything, but the only difference is the operation. What is the logical operation inside the gate is going to happen. So that it will be different. So in NAND gate, NAND operation is going to be done. In OR operation is going to be done. In NAND gate operation is going to be done, like that. So here we have to draw that NAND gate is nothing but, so AND gate followed by inverter, we are getting NAND gate. So like this, your NAND gate looks like this, AB, and the output will be like this. Okay. So then the truth table of the NAND gate is nothing but the inversion of the AND gate. Sorry, okay. Output of the, if this is the AND gate output and NAND, okay. I have to 0 0 0. First you have to write the AND gate truth table. Already what we are discussing before. So 0 0 is nothing but 0 0 0 1. So NAND gate is the inversion of the AND, means 0 means 1, 1 we get 1. So for 0 it will be 1. So 1 1 you get 0, 1 as 0. So here you can invert the AND gate output. So how you are going to write, if both the inputs are 1, our output will become 0. Okay, if at least one of the input is going to be 1, our output is going to be 1. The NAND gate operation is same as the AND gate followed by an inverter. So NAND gate operation is nothing but AND gate followed by an inverter, means the AND gate output is going to connect to the input of the inverter, so that NOT gate output is going to be our AND gate output. Okay. So next one is the NOR gate. So a NOR gate is a digital circuit. It has 2 or more inputs and produces a single output. Same definition for every gate, but the operation, logical operation which is performed is different. Okay. So operation, if both the inputs are 0, our output is going to be 1. How we are going to define this? By using truth table. Okay. So NOR is nothing but OR plus NOT. So OR plus NOT. Okay. So what you are going to do means, see. So first you have to draw the OR gate here, followed by NOT gate here. So AB, we are getting NOR gate. Okay. So this is our NOR gate. Okay. So this is our AB and that output. So draw the truth table for this AB and output of the OR gate. This will be the NOR gate. Okay. So 2 inputs means 4 combination 0 0 0 1 1 0 1 1. So for 0 0 for OR gate we get 0 1 1 1. For NOR means it will be quietly opposite to the NOR. So 1 0 0 0. Okay. So now we are defined this operation. Okay. If both the inputs are 0, our output will become 1. If at least one of the input is going to be 1, our output is going to be 0. Like that we are going to this operation. Okay. The NOR gate operation is same as the OR gate followed by an inverter. So NOR gate operation is nothing but OR gate. So what is the OR gate? Output is going to be connected to the input to the NOT gate, and that output is going to be our NOR gate output. Okay. So next one is the derived logic gate. So that is the third type of logic gates. Okay. So here you can see the first one is an XOR gate. So XOR means exclusive OR gate. So you can represent like XOR or EX, or like that you are going to represent anyone. Okay. So EX is nothing but exclusive. So elaboration of this XOR gate is exclusive OR gate. So the XOR gate produces an output similar to the OR gate except in certain cases. So whereas this XOR gate is, why you are calling this exclusive OR gate, means the operation is somehow same as the OR gate, not completely, in except some cases. See here, it will definition only say that some certain cases, except some cases, it will be similar to the OR gate. That's why we call it as a XOR gate. So let AB and B are the inputs and Y will be the output. So the XOR gate seems like this. So OR gate only. So there is some modifications in the OR gate. So we have to include like this. Okay, A, B, and this is the output. So the symbol is like this. So this will be the XOR symbol. Okay. So A XOR B is nothing but, if you are going to elaborate this A XOR B, so that will be A bar B plus, wait a minute, plus A B bar. Okay. So this will be the XOR B. So now draw the truth table for this A, B, and then output. Okay. So 2 inputs means 4 combinations 1 0 1 1. So A bar B plus A B bar. So now A is equal to 0, B is equal to 0. So how to substitute these values here in this formula. So A bar means 0 bar means 1 dot, B bar means, sorry, B means 0 plus A means 0, dot B bar means 1 bar is 0 bar is nothing but 1. So we get 1 dot 0 is nothing but 0 plus 0 dot 1 is equal to 0. We get finally as 0. So like that, if you done these all combinations, you get the output like this. Okay. So the output, how you are going to write the operation is, see, one output is 1 when only one input is. So see here, it means if the inputs are different, or you can say that if any one of the input are contain 1, or if any one only one only contain the output, or you can otherwise it is different, ignore this point and say like this. How can going to say means, if the inputs are same, then the output will going to be 0. If the inputs are different, then the output are going to be 1. Like that, it is very easy to understand. The output is 1 when the odd number of ones are present at the input. Hence, it is also called as a odd function. So, odd function is not, what is a even function and odd function? I think we are already discussed. So, when in the given equation, if there is a even number of ones, so then it is called as a even function. In the given binary number, if you have any odd number of ones, you can call it as a odd function. So, here you can see, here 0, 1, there is a only 1, 1. So, means 0, 1, we have containing one type 1, 1. So, in 1, 0, we are containing here also only 1, 1. Okay, only one high input. Here also one high input. So then only your output is going to be 1. So that's why it also called as a odd function. So XOR gate is also called as a odd function. Okay. So next one is the XOR gate. So XOR gate. So XNOR. Sorry, XNOR means exclusive NOR gate. So XNOR gate is the inversion of the XOR gate. So what is the XOR gate? This is the XOR gate. So it is the inversion of the XOR, means we have to add the NOT. Okay, A, B, and then output of the this OR gate, XOR gate is going to connect to the NOT gate, then you can get the XNOR. So the XNOR symbol is like this. So Y is the output, means XNOR, sorry, Y is equal to A XNOR B. Okay, our symbol is seems like this. Okay, so how you are going to elaborate means A bar B bar plus AB. Okay, so draw the truth table for this A B and then output 0 0 0 1 1 0 1 1. So this is the XOR. XNOR, you have to invert this thing. Okay, 0 1 1 0 1 0 0 1. So you have to simply invert this XOR gate outputs. So now draw the function, means write the operation. When both the inputs are same, output will become 1. So see here, when both the 0 0 combination and 1 1 combination, you get the output as 1. So both the inputs are equal, means we saying that output is equal to 1. So if the output is equal to 0, when it is going to be 0, when the inputs are going to be different, our output is going to be 0. The output is 1 when even number of ones are present, then it operates as the even function. In the previous thing, it find the odd number of ones, but here see, it find the even number of ones. When there is even number of ones or even number of zeros, then only it is going to be represented as a 1. So that's why you can say it as a even function. So these are the 3 types of gates. Inside the 3 gates, we are going to discuss 3 basic gates, 2 universal gates, and 2 derived gates. Okay. And finally, thank you. Thanks for watching. If you have any doubts in the particular gates, you have to comment for this and keep supporting. And then bye.